Hello and welcome back. In this third video, I'm going to extend the program we wrote in the first two videos to do with the cipher program. And I'm going to add the actual encryption and decryption part. So if we, let's go back to our code. So now I'm going to encrypt, I'm just going to put a little note in here, encrypt or decrypt the text. Now the text we want to encrypt or decrypt is in the variable buff, in the character array buff. And the direction we want to go, whether it's encrypt or decrypt, is stored in the variable dir or dir. So let's think about this problem a little bit. So we don't have a magic program or function in the Arduino libraries to automatically encrypt or decrypt any code like this. So we're going to have to write something. So we are going to need to process the characters in the character array one character at a time, which means we're going to need some kind of loop. And we're going to need a loop that will run for, because we don't know how long the string is, we're going to need to run a loop that will run indefinitely until it encounters the end of the string or the null. So anytime we have that kind of condition, we want to use something like a while loop. So while we're not out of characters. How do we know we're not out of characters? Because we're not at the null. So if I look at buff I not equal to null, that means while I'm not, I can process through the buffer, and while I'm not at the end, do something with that character. Okay, so I introduced a couple of things in there. The other thing is this integer variable, this loop counter variable, I. So I need to set I to 0. Now notice that I don't have to put int I here. That's because it's already been declared up here. And for a variable, you only have to declare it once in the program, and you can use it multiple times. In this case, I declare it once and I'm assigning it, and here I'm just assigning it. So just make sure you don't double. If I did this, something like this, and I, let's just close this off for a second, and I were to compile this, I would get this kind of error. I would see this redeclaration of I, and if I just scroll down here, it's what this is telling me is that the integer I variable has been declared somewhere previously in my program or in this scope, and I'm not allowed to do that. I can't redeclare variables. All I can do is reuse them. So that means I don't need to redeclare them. I don't need to make the storage for them anymore. I just need to update the value of it. So if I compile this, it'll compile fine. Okay, so I've got my loop variable starting at 0, which means I'm going to start at the first character. I'm going to work my way through the list until I get to the end. So I know that because I'm using this loop variable, I better be incrementing that loop variable somewhere, probably at the very end of the loop. So I'll just put that in there right now. So what am I going to do? Well, I don't exactly know how the algorithm is going to work yet, but let's just make sure that this output thing works correctly. So I'm going to, I'm just going to print the character out. Print buff I one at a time, just to make sure that my loop is getting the whole thing. And I'm just going to put a serial.println, empty print line at the end here, because I would like all the characters to show up on the screen in line, and then in the last character I'm going to just put a print line, so the next thing I print will be underneath those characters. So let's see what this does. So what I'm expecting this to do is just go through the characters that I've put in the buffer and print them out, and that's it. And all this is testing is whether or not I wrote this loop correctly. So let's compile that. Okay, so enter the text. Text is apple. Enter the direction, putting in the E. All right, and it printed out the word apple, and that's all I expected it to do. Now, in this program, you don't have to store the encrypted text. You just have to output it, which means you don't need to put the calculated values into another array and into another character array. You just have to output them to the screen. So this is actually step 4 already, which is the output part. So, all right. Because I'm going to do some processing on this character, what I'm going to do is I'm just going to change this a little bit. And I'm going to create a character here, a variable called letter. And we will assign the I buffer to it, just like this. So now I can change this. I can print the letter. Okay, why am I doing this? I'm just doing this so that I have to do some manipulation on this, and I don't want to mess up the buffer that I'm working on. So I'm just going to pull out one character from the buffer, store it in a variable, and then use that variable for all my processing until I read in the next character. So let's just see if my program still works. So this process of making a small change and testing the code, it's called iterative development. And this is the way you should write all your programs. You should not start with a blank piece of paper and write the entire thing from beginning to end in one step and hope that it works. You should write a tiny amount that does something useful, see if that works, and then add something useful, some small modification to it, and see if that works, and so on and so forth until you get the whole program written. So if I enter some text now, Apple, encrypt, okay, it's still working exactly as I expected. So let's go back to our code here and think about what has to happen. Now, if you remember from the lab description, how this substitution cipher or Caesar cipher works is that we want to a character, one of the character that we're working with is in some position in the alphabet, and the character we want to output is offset from that position by some particular amount. And I asked you to use the first letter of your name as the offset amount. So if your name happened to be Charlie and the first letter is C, that offset amount would be 3 because C is the third character of the alphabet. It just so happens that my name starts with C, so that my offset will be 3. And remember how characters are stored in C. They're just numbers that happen to represent, arbitrarily, we've decided that there's some mapping between a particular value and the character it represents. So in this case, we can add our offset of 3 to the numeric value of the character to get the new character. So let's see what that looks like. So what I want to do is something like this. I want to say letter equals letter plus the offset. Now I haven't declared what offset is, so let's scroll up to the top of the page here, and let's just define this thing as an integer offset equals 3. So first letter of my name is C. Okay, so the offset for my program is going to be 3. So if I add 3 to the existing letter and then I print it out, let's see what happens. Let's see if we're moving in the right direction. So if I have my word apple, and I would expect the A should translate into a C, the P should translate into a S, the P should translate into an S, the L should translate into O, and the E should translate into an H. So I should expect CSSOH to show up on the screen when I compile this program. So let's go ahead and do that. Okay, so enter Apple. I'm going to encrypt it. Not that it matters. Okay. Oh, I made a mistake. It's not C. It's going to be D, and that's because it adds 3 to the A position. So 3 from the A position is B, C, D. We're actually in the 4th position because A is in the 1st position. Okay, so now if we look at the code here, notice that I'm not looking at the direction or anything. I'm assuming that we're going to do we're just going to encrypt by default. So we'll add that in a second, but I just wanted to show you that this is the fundamental process that we're going to use. Is we're going to take the letter, we're going to add our offset value to it, and we're going to create the new letter, and we're going to be able to print it out. Okay, so that seems to be working. Now, what about this direction thing? Okay, well, let's see. That means I have to do some kind of test. So if the direction equals E for encrypt, then go ahead and do this. So I'm just going to put this if statement around this code right here. Else, now I could test it. I could say if dir equals D for decrypt, then go ahead and do something. But because there's only two options, I really just have to test for the E. If it's not E, it's going to be D. And now, you're saying, well, I could enter anything. I could enter Q or M or Z. You absolutely could. We are not bulletproofing this program to handle every and all possible condition. We could. That would make the program considerably longer. The programs you write in real life will have to have some of that sort of error detection code in it, just so you don't inadvertently do something that breaks the system or crashes the code or does something unusual when the user puts in sort of unexpected input. And rest assured, you can assume that the user is going to put in unexpected input for any product that goes out into the field. So, but in this case, we have a simple controlled environment, and we just want to look at the fundamentals of the code anyway. So in this case, if I'm encrypting, I want to add the offset, and if I'm decrypting, I want to subtract the offset. Okay, so let's see if this works. I'll put a little comment in. Decide to encrypt or decrypt. Okay. Let's see what happens. So everything is basically the same, except I'm reading in a character, one character at a time from the buffer, and I'm going to print that letter out. And in the middle, I'm doing this little manipulation. I'm adding the offset to the letter if it's encrypt, and I'm subtracting the offset from the letter if it's decrypt. Okay, let's see if this works. So, enter my text, Apple. I'm going to encrypt it. I get DSSOH. Okay, so this is the first time I'm able to decrypt something. So let me type in DSSOH, and I decrypt, and I get the word Apple. Hooray! I have the fundamentals of the cipher algorithm working. It'll encrypt and decrypt this particular piece of text. Now, what happens if I enter something like this? Zebra, my favorite test string. Okay, so zebra, I want to encrypt it. Okay, I'm getting some square bracket HEUD. All right, I'm not all the letter. It should be putting the code in from HEUD, but let's see if it goes backwards. So I'll do that. I'll decrypt it, and I get zebra. Okay, so the decryption seems to be working correctly, but the encryption isn't, because I want to restrict my characters to be between A and Z. And when I choose a Z, or choose any characters close to the end, it's going to fall off the edge. It goes past the Z into the characters in the ASCII table that occur after Z. So I have to fix it up. I have to prevent this from happening, but I can't really prevent it from happening, because if it's a Z, I want to add 3 to it. What I really want it to do is wrap around. I want it to go around to the beginning and choose a character from the beginning of the alphabet rather than at the end. Okay, so how might I do that? Well, let's think about that for a second. I've got the letter. I've added the offset to it. Now, how do I know it's gone off the end? Well, I can test it. If the letter is greater than, now I can look up the letter in the ASCII table for Z. I can look up the numeric value, and the numeric value for Z is 90. It's 26 plus 65. That's 65 is the character code for A, capital A, and 90 is the character code for capital Z. However, I can rely on the fact that the C compiler will do that calculation for me if I use the literal Z character. So I can actually write a test that looks like this. if the letter is greater than Z, then I'm going to do something. I'm going to do something to this letter. I have to make it wrap around. So how can I figure out how to wrap it around? Well, if the letter is Z, if I skip ahead 3 and I start counting from the beginning, I should go A, B, C. I should end up at the C, letter C for Z. If it was Y, I would end up at the letter B. If it's X, I would end up at the letter A. All right. What now? That's if the offset is 3. If the offset is 17, if your name happens to start with an L or a Q, then you're going to jump much farther. There's going to be many, many more characters that have to be mapped. So we need a kind of general purpose algorithm that will allow us to wrap around to the beginning of the alphabet if we happen to fall off the end. So, and because we don't know, I happen to be starting with Z, but if you had a 17 character offset and you started with T, that would put you past the Z, but not 17 characters past the Z. So what we want to figure out is how many characters past the Z we are, and then tack those onto the front. All right, so how can we do that? Well, we could say that because the letter is numerically bigger than Z, it's going to be 91, 92, 93, we could have the letter subtract the Z value. Okay, that's going to give us sort of the difference between the end of the alphabet and our new character. So what do we want to do with that difference? Well, we would like to start from the beginning and add it on to the letters at the start. So why don't we start with the letter A and we just add this this difference onto it, and we'll assign that to the letter again. So now we're saying if the letter is greater than Z, take letter minus Z, that'll give us some number of characters past the Z, and add it on to the A. Okay. And give us a new letter, and that'll calculate a new letter position. So let's see what that does. Okay. Enter the text. I'll enter, well, let's say I'll enter Apple just to make sure it's still working. E. Okay, I get a DSSOH. DSSOH on the decrypt is still Apple. Okay, so let's try our zebra. Zebra, encrypted. Okay, I'm getting a D. So D is the 4th character. So if I start counting from Z, I go Z, A for the first, B for the second, C for the third. So I would like it to end up at C, but I've ended up at D. I'd like it to end up at, I would like it to end up at D. I'd like it to end up at C. So why isn't it ending up at C? Because I'm counting from A instead of including A in the count. So I've actually gone past, I've gone one bigger than I want to. So what I can do is I can just subtract 1 from that position, and that should put me in the right place. Okay, let's enter the text. Zebra, encrypted, chewed, CHEUD, decrypt. Okay, that's not working. Okay, so the decrypt's not working, but the encryption's working because it's getting me to the right starting character when I wrap around. Okay. What happens with my regular letters? Apple encrypt, DSSOH, and decrypt. Okay, so the decryption's still working for that. All right. So far it looks like our decryption, our encryption algorithm, and that handles the wraparound to back to the beginning of the alphabet seems to be working. Let's look at the decryption. So we're going to have a similar strategy here. We've got letter equals letter minus offset. So now we don't want to check to see if it's bigger than Z. We want to check to see that it's bigger than that it's smaller than A. That means we've fallen off the front end of the alphabet rather than falling off the back end. So letter. Okay, so if this is the case, if we're at less than 65, less than the letter A, what do we want to do? Well, we want to do something similar to what we did before. We just have to rearrange it. We want to know the distance we've fallen off. So we want to take the value, the distance from the A letter, the letter A, to the letter we've calculated. Now, because the A letter is bigger, we'll just subtract letter from it. So that gives me the distance that I'm past the end of the alphabet. And now I want to walk backwards from the Z backwards up the alphabet until I get to the right letter. So if I've gone past 3, if I've gone 3 past the A, I would like to go Z, Y, X. I'd like to end up on the X. So I would do something like this. Z minus the letter. Now, I don't know. Likely I'm going to have to add 1 or minus 1. I'm not sure. So let's just see what happens here with this part. Okay, enter the text. All right, we can enter something easy like A, just A, the letter A, and we'll see how far it goes backwards. So if I enter the letter A and I want to offset it by 3, I want to end up at the X. So if I enter this, and I'm going to decrypt it this time, I've ended up at something, a greater than sign. That's probably not right. So let's see if I should subtract 1 from it. So I'll put this, put a minus 1 in. Enter the text. A. I want to decrypt it. Okay, we're still at. We are still at the greater than sign. Okay, that's unexpected. Well, let's see what happens if we add 1 to it. All right. Download that, enter the text A, decrypt it. Okay, well, it's pretty obvious why that's printing. Here's the problem. The problem is that in my code, I never assigned letter the new calculated value. So even though it did the calculations, it just went off into the bit bucket and we never saw it. So let's go back to our original code with a minus 1 and see what happens here. Okay, we'll put in the A. I want to decrypt it. Okay, I've got the letter V. I've got the letter V, so I'm backing up. I've gone 3 characters, so that's I'm starting from Z, so that means I've gone Y, X, W, and then I'm taking another one off, which means it went to V. I actually want to go the other way. I want to add 1. So let's add 1 here. Enter the text. It's A. Enter the direction decrypt. Okay, now I'm at X, and that's exactly where I expected to be because X is the 3rd character in from the end of the alphabet. Okay, let's see what happens with a real word. Zebra. Enter the direction, encrypt. I've got Ched, C-H-E-U-D. I've got to decrypt it. I got zebra back. Let's try apple. I want to encrypt it. DSSOH. I want to decrypt it. I've got Apple. Now, this, whether you're encrypting or decrypting is somewhat arbitrary. I could say Apple, and I could decrypt it, and I end up with XMMIB, XMMIB, and now I want to encrypt it, and I get my regular Apple back. So I'm just going backwards and forwards in the alphabet. So this is in fact the whole program. Let's just go through this little encryption decryption algorithm again. For every character in my buffer, I'm going to read a character in. I'm going to decide whether to encrypt or decrypt. If my direction is E, I'm encrypting. I'm going to add the offset. Then I check to see that the letter, if the letter is fallen off the end of the alphabet. If it has, I calculate what the distance is off the end of the alphabet. I add it onto the A, and then I just correct. I step back one step because I don't want to start from A. I want to actually start from the position just prior to A. So this corrects my character position, and I get the new letter. If I'm decrypting, I'm going to subtract the offset from the letter. I'm going to check to see if I've fallen off the end of the alphabet. If I have, or I've fallen off the start of the alphabet, and if I have, I'm going to calculate the distance that I've fallen off. I'm going to subtract that from Z because I want it to wrap around to the end of the alphabet and then move backward through. And then I'm going to add 1 to it just to take into account that I'm not starting from Z, I'm starting from the position just prior to Z. I'm printing the letter out, and I'm incrementing I to get the next character. And then at the very end, I'm doing an empty print line so that the prompt will appear on the next line. So just for completeness, I would put some, I should have done this at the beginning. Say, what's this program? It's called the Cipher program. Description, encodes or decodes text. Oops. Encodes or decodes text entered by the user using a substitution cipher. Written, let's say who. In my case, it's me. You would put your own name here, and you might put when. And you would say, whatever, November 28th, 2017. Okay, so there's our whole program. And we'll just get rid of some of these empty blank lines here. And now that I put those comments in, let's make sure it's still working. So Apple works, I hope. Encrypt, DSSOH, decrypt, Apple, zebra, encrypted, chewed, decrypted, zebra. Okay then, that's the entire Cipher program actually. I hope your program looks something like this. This is not the only way to solve this program. There's actually a variety of ways you can do this encryption and decryption. You can put the if statements inside rather than, or you can put the if statements outside the while loop, but then you've got to duplicate the while. So it's up to you how you want to structure it, but this will give you the basic approach.